Hi, my name is Dimitri, and today I'm going to be talking about inductive heating. So, what is inductive heating? Inductive heating is a flame-free and contact-free way of heating up metals. A basic example of inductive heating is composed of two parts, the work coil and the workpiece. The work coil is a coil that is usually made of copper tubing. The workpiece is a conductive material that is placed within the coil. Although copper is most used industrial as a work coil, any low resistivity metal such as brass and aluminum would work. This is because the low resistivity causes these materials to take longer to heat up. One would most likely use a material with a high resistivity for the material for the workpiece, such as iron or tin, because the high resistivity allows them to heat up faster. One should also note that materials have a lower resistivity when they begin to heat up. So how does it work? A current is first put through the coil, which causes an alternating magnetic field to surround it. The more coils around the workpiece, the stronger the magnetic field produced becomes. This causes eddy currents to flow within the workpiece perpendicular to the magnetic field. When these currents flow through the workpiece, the resistivity it has causes itself to heat up. This is because the object is impeding the flow of electrons. This is called Joule heating. These effects are due to Faraday's law of induction and Ohm's law. Another effect that causes the workpiece to heat up is hysteresis losses, which occurs due to the material's resistance to the change of a magnetic field. This effect only takes place in magnetic materials such as iron and will not take place in non-magnetic materials such as copper. This effect does not produce as much heat as Joule heating, but does play a role in heating the workpiece. When creating an inductive heater, you must consider the optimal way to create a magnetic field. This is why a coil is usually used, because it allows current to flow in the same direction. If the currents were to oppose each other in direction, their magnetic fields could cancel out, causing the inductive heating not to occur. So here, the visualization on the top, this is an example of eddy currents. As you can see, the eddy currents are going perpendicular to the magnetic field. And on the bottom, here's a visual of hysteresis losses. So what is inductive heating used for? Well, there are many different applications. Here are just a couple. So here, this first picture is an example of welding. The second one is of brazing, and then the final picture is of soldering.